All right, hello everyone. Today I'm going to be describing my BTC stack setup. I've been working on this for a few months, getting it working in the way that I want. So this is a fully self-hosted setup here, and there are a lot of tutorials and blogs and probably even books about how to do this, but I didn't really find any that provided the level of detail that I was looking for. There's also products you can buy, like Raspberry Bolt and Start9 and Umbrel. I haven't used any of those, so I can't speak to how they are. I've read good things, but I decided to go my own way here, and really the intent was for me to learn about how the different pieces fit together in a functional Bitcoin stack. And so yeah, now that I have it working, I just wanted to share it with the world. So today I'm going to be going over it at a high level. I'm going to be drawing a diagram. There's not many good diagrams, at least that I've seen. There aren't many good pictures out there of just like how the different pieces work at like a basic process and port and networking level, like a schematic of how the pieces fit together. So I'm going to do that first, so we can get a high level understanding of what's going on. And then I may go over, in a later video, I may go over some of the other details that I've, and some of the things that I've learned. Okay, so just for the setup here, I've got a terminal on the left, and this is me SSH'd into my PC, the PC that's in my closet that has all this code running. So I can draw a little picture, a very high level picture. So I have a miniforum PC, and so that's like this guy right here is the one I got. It's a little more expensive than the Raspberry Pi, but it also is a bit more capable. It has the one I got is an i7 12th gen Intel CPU, and it's got 16 gigs of RAM. So it's a little more speedy and capable, actually capable of handling some light web traffic, which, as we'll see later, is needed for my particular use case. So I also had issues with Raspberry Pis. I have two Raspberry Pi 4s, and I tried to use them along with an external USB drive, external USB SSD, like a high-end one from Samsung, and the Bitcoin blockchain failed to sync. And I don't know, it was weird. There were weird bugs. I might just try it again later just to like report the bug and see. But at the time, I couldn't figure it out. The first time it happened, I was like, well, maybe it's just a one-off device error. And then I did it on another Raspberry Pi and a different USB drive, and the same issue happened. So I suspected it was something with the Raspberry Pi, and I switched to this miniforum guy here, and it worked. So that's what I went with. Anyways, I have a miniforum PC like the one we just saw, and It's a headless PC. It doesn't. It's just I basically have it on my local home network, and I SSH into it. And this is what you're seeing here. On the left is the terminal for that PC. And yeah, anyways, so now I'm going to go into the basic pieces of the Bitcoin stack that I'm using right now. So the first one, which is probably no surprise, is you're going to need Bitcoin D. And oh, by the way, I'm using the miniforum BC is running Ubuntu. So yeah, I guess at this bottom layer here, I've got Ubuntu 2404 and then let's see, we've got Bitcoin D. That's the first good one to talk about. So this one, there's a ton of guides for this. Setting up this in isolation is very easy. Let's see, if there's anything to note here for my particular setup. By the way, I have all of these scripts that you see here on the left. I'm going to be publishing to my GitHub, so you can use them if you want to. The one thing when I was trying to figure out how to get this to work, one problem I was wrestling with was how I needed a public IP, because my end goal here was to set up a self-hosted BTCPay server. And I wanted to access the BTCPay server from the public internet. Yeah, so I wanted to access BTCPay server. So I needed a public IP. The one locally, like from my local ISP, in order to get a static IP, it's about double my current internet costs. And also it's a bit revealing in terms of location. And I wanted to avoid that. And so I was thinking I need to come up with something that uses like a cloud provider, uses an IP from a cloud provider, and then, but I didn't want everything to be in the cloud provider, because as most of you probably know, the Bitcoin blockchain is, well, let's see, how big is the Bitcoin blockchain? 600 gigs? How big? Actually, I can probably do this with my actual node that's running here. How do I query the Bitcoin block size? Okay, so you can actually check this from my own node to see how big the blockchain is. Let's see, BTCLI, get blockchain info. So this is from the actual blockchain on my own node, and this is saying size on disk is 716 gigabytes, roughly. Yeah, so that's pretty. That's quite a lot. And if we go to, I've been playing with Mixtral, but also Gemini. I'll see if Mixtral can tell me how much does storage cost per gigabyte on AWS. Varies depending on what you're getting. So I would probably get a general purpose SSD. It doesn't need to be like particularly performant, especially after it's synced. So I'd probably get this. So 10 cents per gigabyte per month. Per gigabyte month. Per gigabyte month. So 10 cents, let's just say 10 cents times, how much should I say? So that's per gig, and I have 716 gigs, approximately. $71 per month. So it's really not economical to run, at least for me, to run a Bitcoin node with the storage hosted on a cloud provider like AWS. I'm sure there may be other cloud providers that are cheaper than that or more expensive, but it's quite a lot. And the Bitcoin blockchain grows all the time, grows every day. So that cost is going to go up every month, and I guess it'd be a linear fashion because blocks are added. A new block is added every 10 minutes roughly, but so it would be predictable, but it's linearly going to get much more expensive. And $71 right now to host it. So I didn't want to have the Bitcoin blockchain stored on AWS. So I need a IP that is publicly accessible. AWS is great for that. Other cloud providers too, but AWS is the one I know. And I don't want to store really any data on AWS because it's expensive. Much more expensive than just renting out an IP address. So back to this guy. This is running. This guy is running on a minis forum PC in my closet. And plugged into this is a USB drive. Oh my gosh. Why doesn't the little arrow get straight? That's so infuriating. Oh my God, why? Don't they know people have OCD and they need a straight arrow? Okay, well, I'll just do this over here. So this is USB-C and storage. And this is going, so this is the Bitcoin data there. All right, I'm going to group these things and then slide them down so we can see them a bit, or make more room for other things. Oh, I got the straight line. Look at that. Let's go. Okay. Oh no. Okay. I'll keep it there. So this is USB-C cable there. I guess it really should be. If we're getting technical, it should be a double arrow. Yes, a double arrow. Bidirectional. Bidirectional data. Okay. USB-C cable. Okay, so you have, oh shit. You have Bitcoin is code that's running on top of this PC. And let's zoom in here a bit. So Bitcoin is going to have one of the main parameters is the data dir. So first of all, the Bitcoin configuration file lives in it lives in different places. On my setup, it lives under there in this file. The configuration controls everything. So, and the configuration file that ships with the Bitcoin source code is actually pretty good documentation. It lets you set things like for example, the port that Bitcoin is going to be listening on for the peer-to-peer Bitcoin protocol. And by default, it uses 8333. You could change it if you wanted to. I didn't, but you could. There's a whole host of configuration items that you can read about in there. And one of them, which is relevant to this picture so far, is called data dir. And I'm gonna zoom this page a bit. I think I can. There we go. It's a little easier to read. Okay. So data dir, and this in my configuration is set to var_lib Bitcoin D, I believe. Set up Bitcoin node var_lib. Yeah, var_lib Bitcoin D. So this on the left is my setup script for Bitcoin and Bitcoin D, and I just had to refer to it real quick. So this is Bitcoin D. Okay, and so then this is the directory that Bitcoin is going to be using to put all of the blockchain data, all of the data that Bitcoin D uses is going to be put in that. All of it's going to be put in in this directory here, varlib Bitcoin D. Oh, there's a typo here. Coin. I think I can move this to the top. How do I do that? There we go. Yeah. Okay, and so this is this value here, datadir, is actually specified in the Bitcoin configuration file. So this this setup is pretty much complete. The only thing here is that I added a systemd mount service to mount the USB drive to this, or I guess mount this directory on this USB drive before Bitcoin D is getting started. So let's do a little, let's group these. Group. Did it actually group anything? Nope. And they're gone. Okay, why did you do that? And what is this square coming from? Like, what is this? I don't know what that is. I guess it may have been the grouping that I originally did on group. Where did it go? Okay, send back. There we go. Now I'm going to group it again. Group. There we go. Ah, there we go. Okay, so I guess I can anyways, yeah, so this has a little dependency here, and this is the dependency is a systemd mount file, and which is defined as such. So it's a pretty self-explanatory: mount external storage to varlib Bitcoin D. So the device, this @device@ is a placeholder for my script, and the script setup Bitcoin node. If you look for the device, right here, it's this is the part of the script that's responsible for mounting the device. So the directory gets made here, varlib bitcoind. And this part is what actually mounts the USB drive to varlib bitcoind. The only thing that's of note here really is that this mount file has to match the directory names, basically the path of the mount. So varlib bitcoind, /var/lib/bitcoind, that has to match, right? So you're using every single directory that's in the path is included in the mount file. That's just a quirk of systemd. And again, this is what it looks like. So it's pretty simple. So this device is a placeholder that gets replaced with the actual device that you pass in. So this thing here is, so this sed is searching for this pattern in this file, and it's replacing this pattern with the mount device that you provide as an argument. Remember, this is an argument up here, way up here, mount device. So yeah, the script checks for the existence, and then so I'll add a little section here for varlib bitcoin d.mount. So this is a systemd mount point, and it is a dependency. So bitcoind depends on this systemd service in order to run. So if I do bitcoind service, you can see that this is the service file for Bitcoin. So actually, like, running it in the background all the time, and then when it boots up, it's using systemd. This is let's see, where is it? Var. Okay, yeah, so this, it's kind of implied, but the state directory, anytime you define state directory for a systemd service, you give it the leaf directory, and systemd then assumes that it's going to be under var/lib. Systemd is confusing. It's all in the documentation, but this is how you get the varlib bitcoind. State directory is varlib, and then you tack on the directory that you want for your actual service, which resolves to varlib bitcoind. Similarly for these directories up here. I have them all commented, but so, and when you do that, systemd adds a dependency. So basically, if systemd sees a mount point or a mount service like this on varlib bitcoind, such as the one that we defined here, systemd adds an implicit dependency for this service on that mount point. What that means is that bitcoind doesn't start until this mount point is done. In other words, until the USB storage device has been mounted onto this directory and the data is available. Okay, and let's see, I think that's the only other, I don't think there's any other dependencies here. Other than the network, Bitcoin needs a network, obviously. So we have depends on the network online. I think the only other one is varlib Bitcoin D. I also took the liberty to modify this service file also ships with the Bitcoin source code. I took the liberty to add some additional security hardening measures here that are just missing from the upstream code base. And since Bitcoin is a networked process and is participating in an adversarial network, we want it to be hardened as much as we can and make sure that our system is being isolated from a potentially rogue or compromised Bitcoin process. So that's what some of these systemd knobs are for. They essentially restrict what Bitcoin D can do. And so in the off chance that Bitcoin has a remote code execution vulnerability, then the attacker with code execution on my machine that's in my closet, this stuff right here makes it more difficult for the attacker to pivot into the kernel or into other processes and trying to get prevents it from getting other assets that may be on there. So, okay, so, which, by the way, I don't have, I do have a small amount of sats in my LND wallet that's running on this. I'll get to LND later, but I don't have any substantial amounts of Bitcoin at all on this machine. It's all, everything else is stored separately. So I think that's all that I wanted to talk about Bitcoin, except for the way that it's going to be talking to other things. All right, so I've got the mount explained. Systemd then does the actual mount for the USB drive. This, I wonder if I can, so I can add a little label there, systemd mount. Actually, I'm going to do it over here. Or maybe just right under it. Systemd mount. And then I can pull this up a bit. Slide this down. And then we can arrow this. Whoa, why did it jump there? That's pretty questionable decision. Okay. Except this needs to be a double arrow. Single arrow. That's like a dependency, so whatever. Okay. Cool. System. Okay. All right. So what else? Oh yeah, ports. So okay. Bitcoin is going to have some ports. And I'm gonna put those. Let's see, I put those little boxes out here. So we've got port 8333. This is the peer-to-peer port. And I'm gonna rotate this, and I need to make it, I guess I can, let's see. I rotate the text at all? I guess I can just rotate it again and then make it small. Okay, so we have the peer-to-peer port. So Bitcoin has several ports. When you're on mainnet Bitcoin, talking to other Bitcoin nodes, you're talking over port 8333. And and that can be done either over clearnet IPv4 traffic, or it can be done over Tor. And my setup now is using Tor only, and I'm going to get into the Tor setup later because I use it with Bitcoin D, and I use it with LND, and I also use it with electrs and Zeus, my Zeus mobile wallet for connecting. Anyways, I'll get into that. So this is the port that the main Bitcoin protocol is communicated on. I'm going to duplicate this, and I'm going to call this one, so 8332, and this is RPC. So the RPC is for, well, there's a lot of things you can use it for. It's useful for querying the state of the blockchain, of the Bitcoin daemon itself. It's what the CLI uses. So I have BTC Bitcoin CLI here. You can see in my terminal on the left. This is using the RPC parameters they're already in the configuration file. And basically you can make calls to the RPC interface on 8332 and get information. You can also write information. It's not just a getting thing. But yeah, the command I used earlier to get the blockchain info, it's using RPC calls. So you're going to need this. I don't have it exposed to the internet or even over Tor. I just haven't really had the use case for that. And at least I don't have it directly exposed. There are other processes on the system that are using this port and use it quite a lot. So I'll be picturing that later. Okay. All right. So I think that sums it up for now. The like I said, the scripts, my scripts directory is going to have all of these systemd service files and bash scripts that you can use. So now let's move on to I'm actually going to do electrs next. So electrs is a thing that I added. I honestly don't use it a ton now, but you think of it as like a server that you can connect to either as a Tor hidden service or over the clearnet IP address if you want. And it's used by a lot of Electrum based wallets. So I think Sparrow is one. Sparrow. Let's see. Electrum wallets. Let's see. Electrum. So Electrum, I believe it's a protocol. Electrum Bitcoin wallet. They have a mobile wallet. So it's basically a wallet, and you can connect to your own node from your phone to your BTC node. And Electrum is like a thin interface on top of the BTC RPC interface. So if I think this, I can say electrs. Electrs is the Rust implementation, and it's one of the things that's, let's see, where should I draw this? I'll just draw it here for now. So this is talking locally to the Bitcoin node at that interface. Should be, yeah. And so this is yeah, so you have electrs. It's providing a thin wrapper over this RPC interface from Bitcoin. So it allows you to like look at your wallet status and look up transactions and so electrs is a way to access. It's kind of like a shim that allows you to access. Say you're out here and you have your phone. Draw a little phone here. Phone with Electrum. It's a pretty big phone. But this can connect to the electrs application that you're, okay, I need this square elbow connector. Where's the elbow connector? Double elbow. No? Oh. Okay. So this connects here. And this. So this is running, remember this is running all on, let's draw a dotted line here. So this is running, this is like the boundary of the PC, the network. So you have the, everything that's below this line is running on this PC in my closet, right? Okay. So, so this is neat because it allows you, electrs allows you to access your Bitcoin node from anywhere in the world. You need an internet connection. And then this electrs, so the electrs service itself, I can't remember off the top of my head. I think it's, let's see. So this is the configuration. It's very simple. So you have the RPC address, which is 8332. So this is the electrs config. Okay. And this, again, this is in the my scripts directory that I'm going to be publishing. 8, so you list out the ports for your Bitcoin node. Nothing crazy here. There is a electrs settings itself. So electrs is a server. It's serving up at 50,001 on my machine. So let's do another port. Duplicate. So this is 50,001. And this is Electrum. And let's move this over here. There we go. Okay. And I'm actually going to group these guys. Okay. So electrs is serving basically all of its functionality over this port 50,001. And so Electrum, it's a wallet, right? So you can provide multiple, you can access Bitcoin and you can verify transactions using your own node, right? So like if you want to not trust a third party that says, hey, your transaction's good, you can connect to electrs. Electrs will then do local RPC calls to your Bitcoin node, and then it uses the source of truth that you host yourself, right? So like the storage and the blockchain data is all stuff that you are verifying yourself. And so it eliminates the need to trust a third party that may have access to their own copy of the blockchain, but could potentially serve up a wrong or a incorrect information saying that, oh yeah, your transaction is confirmed, when it's actually not. So this is a way to increase your, I guess, your sovereignty, right? And the way this is set up in my system is that this is actually being tunneled. Oh, why did it bend? Whoa, 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 whoa. Oh my God. So this is actually being, okay, let's just, so this is being tunneled over Tor. Tor here, and okay, and we can do copy, paste. This needs a paste. Why did it? Okay. Why is it? Okay, I want the double arrow. There. Oh man. Dry O is a good test of patience. Oh. There we go. Wow. Okay. So in my setup now, this is being tunneled over Tor, along with a few other things. Okay, so anything else? I think this also has a systemd file that I've written. And let's see, it's pretty similar to the Bitcoin one. There's nothing really different or notable here. Okay, and so that's electrs, and like I said, Electrum, it's a wallet that allows you to be fully self-sovereign from the node, from the transaction up, right? So you're able to verify everything yourself by connecting to your own Bitcoin D, and you can still do this without we still don't have a public IP. Okay, so this is still, there's no public IP here yet. Everything below this dotted line is internal to the PC. So it's all, this is all just localhost, right? And perhaps I can make style. So style. And is there a dash pattern? Yes. Didn't work. Dang. I just want it to be dashed. Text. No, not the text. Oh. Shadow. Ooh, shadow. Whoa. That's kind of interesting. This guy, I just want, oh, there we go. God, okay. So yeah, I guess I'll just leave the local host connections as, so this would still be localhost. Okay. This isn't really, this is just like a dependency. I could do that maybe. Because Bitcoin D depends on varlib bitcoin d.mount. What I'm going to do is name this as the systemd file, and then this is going to be electrs.service, and then this is going to be, so this one, did it? There we go. put systemd in here. And can I put a border around this? And we're going to round it. Oh. There we go. It's looking better. So the dot followed by the arrow, that's a dependency, systemd dependency. And I wonder if I could, I wonder if that can do that. Oh yes, I like that. And then that guy. Oh, that was much smaller. Okay, that's kind of cool. All right. Okay, and so this is pretty much it. For electrs. Electrs is pretty straightforward. And I wonder if there's a phone icon. Oh, there is. They've got everything. Man, I'm really going deep here. Let's see. I mean, Android. Could do that and then just make it smaller. So I'm going to have other mobile apps as well. So I have my actor here. This is Mr. This is Mr. Satoshi. And he has a, you know, like a pretty fancy phone. This guy's got like, what, one tenth of all Bitcoin. So he's probably got a nice phone. And this, I can actually draw. Oh, this is great. Okay. So Mr. Satoshi has a phone and he would like to connect to his wallet, right? And he wants to do it over Tor because he doesn't want to expose his location, VIP, privacy, blah, blah, blah. So he, I wonder if they have an app icon as well. Oh, they have AWS symbols. That's going to be handy as well. For now, I'll just keep it uniform. So this is the Electrum app. Okay, and that's connected. Actually, so, okay, this is where it's going to get. This is where I learned something here. So Electrum can use. Electrum uses, at least on Android. I don't have an iPhone, so I don't know about iPhones. But if you have Orbot running on your Android, then Electrum uses Orbot. So, or it allows you to proxy. You can enter in proxy information and proxy through Orbot, and Electrum doesn't like try to do it itself. So I'll do another one here. This is going to be orbot. Oops. And why did it do that? So this is running here, and Electrum is running. I'm going to put it kind of to the side. I'm going to remove the app. That's kind of implied. And okay, and then this is, connected directly to the phone. Do that there. Okay, so you have a orbot is being proxied through or rather the connection to your electrs service is exposed over Tor as a hidden service. I'll go over that later. And then you give the client authentication of the Tor hidden service to orbot, and then you tell Ethereum to proxy through orbot. So this is another localhost connection. Copy. Localhost on a different host, but drag here. Okay, and so you have a, this is how it kind of looks on my phone. There's a hidden service, and I guess I should probably go over that. So Tor hidden services, this is using a v3 hidden service, Tor v3 hidden service, and so let's see, we probably should do this. Looking for the authentication, client authentication. This is interesting. That's not what I'm looking for. But a Tor hidden service allows you to expose a web server over the Tor network. And this is really useful, even if you don't care about the privacy part of that you get with Tor. You get it automatically, right? It's because the Tor hidden service is just, it creates a public-private key pair, and the address of the service is the public key, and it's very difficult, extremely difficult to figure out what your actual IP, clearnet IP may be, just given a Tor add a public key, a Tor hidden service public key. So But the other thing that it does is it allows you to access the service over the internet without needing a public IP address. And so the requirement is that the thing that you're accessing the service from has a Tor client installed. So like your phone or a laptop or whatever, and you can access, as long as you have access to the Tor network on your other client. So like your phone or your laptop or whatever, as long as you have Tor access, you can access the service. And another thing that's interesting with v3 hidden services is that you can make it so that it's authenticated. And so if you're concerned with actors on the Tor network itself trying to fuzz or interrogate or trying to break into the service that's running here, you can authenticate the service with Tor, so that the kind of like SSH, where you only allow certain identities to access the service on the clients. You only allow certain client identities to access the service. And so I can just show you what's involved with that. And let's see, I have a script here for helping with this. Basically, let's see. Hidden service. So this is the part in the Tor configuration where you actually configure any service you want to expose. You can add an entry here. So I can just show you my setup. So you can see I have a couple defined. This is the one for electrs itself. So when you make this entry in the config file, you can name this part anything. Then there are certain things that are created underneath it by Tor. This is just the port mapping. So basically it's just an identity mapping. And you can see the explanation here. X, Y, :Z says the redirect request on port X to the address Y, :Z. So any request at 50,000.001 gets redirected by Tor to localhost 50,000.001, which is where electrs is listening on. And I have another one for LND, the LND REST API as well. Okay, and after that, once you have that, then the other thing that you have to do is, let's see, you need to, so this is the hidden service directory. Let's see, this is created by Tor, and you have the public key of the service for the Tor network. That's kind of like, you can think of it like as its address. Actually, its address would be hostname. There's the secret key, which is used for encrypting the communications, and then you have authorized clients, and these are clients that I have authorized to access this service. So if you don't have this, then if you don't have this client authorization, then anyone that knows the host name, anyone that knows the Tor address, or the onion address, can talk on this port to my electr service. And I didn't really want that. I just want it to be, I want it to be the apps that are under my control, and it's much easier to reason about from a security perspective, reduces attack surface, things like that. So I wanted to only authenticate my client devices. So I have a Pixel 8, so that's what this one is. And so if you go to Tor v3 hidden service client auth on Google, then they have a pretty good explanation here. And basically you have to generate client keys, and you need to copy those so that the private key goes on your client device, and the public key goes in the auth directory that we just looked at. So you can see the explanation here. Hidden service dir authorized clients. Each file in that directory should be suffixed with auth, and its content format must be the following: auth type, key type, base 32 encoded public key. And so Tor is going to check that public key value and is going to use that to verify that the messages are signed by only the expected clients. And let's see, on the client side, so Orbot actually allows you to input these parameters. If you go to Orbot and go into the settings, and there's one option called client authorization, and you just import auth_private, and it that's that private key that is referenced here. So I have a script for generating both the public and the private key, so which will be part of the GitHub repository. And it just takes the hidden service directory and the name of the client, and basically just implements what's on this page over here from the Tor project, and creates the private part and extracts the public part from it, and then writes the public key to the server. So I'll go back to my picture. The public key, I'll change this a little bit. So this is Tor v3 hidden service with client auth. And so this is going to have, I already went over the config file change in Tor RC, just defining the directory. And then you need the client public key under the authorized keys, under the authorized clients directory. So, and then this is going to, here, I'll just run the script. This isn't going to be used for anything, so the private key is useless. So gen, so actually, let's see if they, so this script assumes that you've already modified torrc. Should probably add a check to make sure that the directory exists. That's okay. It's pretty self-explanatory. You modify torrc, and then run the script to get the key, the public key, and copy that over, which the script does it for you. And then you have to copy the private key to your Orbot instance. Okay, so that's that part. Okay. That's fine. Okay. So that is, I think that's pretty good for electors. All right, so I'm gonna add the dependency here. So electors depends on Bitcoin D in term from a system D perspective. That was the opposite direction. Oh my god. Copy. Paste. So this goes here. There we go. This goes here. This goes here. Okay. This comes out a bit. There we go. System D dependency there. localhost network traffic, and then this is out. This is going out over the Tor network. Let's see. There we go. This up a bit. Okay, cool. Okay, so now the next one. NB Explorer. This is used for BTCPay. Do I want to do that one next, or I think I'm going to do LND next. Actually, now that we have kind of an understanding of, or we've touched on Tor, I'll go ahead and add the Tor connection, because my Bitcoin D is doing its Bitcoin talking over Tor only. So the Bitcoin conf onion only onion? No. Only net onion. So this is so Bitcoin itself is talking. So I'm not using a I'm not using a hidden service, or I'm not using a hidden service at all. It's just anyone with the the onion address, which it gets broadcasted. I want people to be able to reach it and know about the address and all that stuff. So I'm not limiting it to only like other nodes that I control. I want every node that wants to be able to connect to it. So I'll just copy that, paste, and this is just going to be Tor. Tor with no client auth here. And we'll do an arrow. Copy. Paste. Like that. So that is that port's talking to the Tor service on the miniforum PC, and then this is talking to the rest of the Bitcoin network. So I guess I could draw a bubble here for that. I'm actually gonna group these. Group that. Group. There we go. Make some space for the Okay. And so this can be moved up a bit. And this is the Bitcoin network. And this is talking to that over Tor. Okay. And there we go. Okay. So that's good. Let's do LND next. So LND is the Lightning implementation that I'm using. There's two big implementations. There's LND, which is on GitHub here, and C Lightning is the other one. So C Lightning's it's written in, I guess okay, it's called Lightning now, but this implementation's led by Rusty Russell, who's like an old school kernel programmer before he started doing Bitcoin development. And then the other one, LND, which is the one that I'm using, is written in Go. I've never used C Lightning. I just picked one and they seemed pretty comparable. There's other people that probably have more opinionated thoughts on which one to use, but this one, LND, seemed fine. And so it's basically a pretty similar, follows a pretty similar pattern. I have the LND, I have a setup script for LND. Very similar to the other scripts. It downloads it, verifies the release, makes some users, it verifies timestamps. What else do we got here? It does some configuration, and yeah, I mean the script should do most of it. So this RTL, that's actually, I'm not using that right now. I recently I started using Lightning Terminal instead of RTL, so I need to update this, but so I'm just going to comment this out. This is all RTL stuff here. Oh, and that's at the end. Okay, it's still there, and it does work if you want to use RTL. I'm not using it right now. And I have another script for litd, which is Lightning Terminal. And so if I take this, copy, paste. So this is going to be LND. There's an LND service, systemd service once again. And the port is wrong. It's going to be, well, so there's a few. for LND. Let's see, how should we draw this? There's going to be 9. The main port is 9, 9, 1, 9, 1. 9173? No. 9713? Let's see. This configuration file is really very busy. Let's ask. What are the ports of LND? gRPC 10,009, REST at 8080, WebSocket 9002, and then the Lightning Network itself is 9735. Okay. And all of those are configurable from LND. I didn't deviate from any of those. So we've got 9735. 9735. This is Lightning Network. And so let's see, I'll put the port. I guess I'll put it there. So Lightning Network is going to publicly, it's reaching out on the network. And this also is going through Tor. And this is okay, and copy. I guess I can just move it down here. Okay, and there we go. So this is the Lightning Network port here, and it's also, so I've got a crooked arrow. I'll duplicate this. This is going to be Lightning Network. And we've got arrow. Okay. And then let's see. All right. This is also talking to Bitcoin, the Bitcoin D. Move this up. Oh. And let's see. It is talking to 8332, I believe. Must be. It's not on the peer-to-peer network. All right, so I'm just going through the LND configuration here. And so I have listen localhost. That's because of the Tor configuration. I have some debug level stuff set. The name of the node. And we're using Bitcoin mainnet. We're using Bitcoin D. We set the Bitcoin D dir data directory. So LND talks to Bitcoin D via Bitcoin D's RPC interface. And LND does authenticate. Remember this interface here on Bitcoin D, port 8332, is authenticated. And so one way of doing that is that Bitcoin provides a cookie value that acts as a authentication token. So that's the location of the cookie on my system. And LND is given access, is able to access that, read that file because of the group permissions for LND I've given it access to that file. So I'll go ahead and add an arrow here between LND and the RPC interface. And I'll make a note. This is authenticated. Cookie file. Authenticated with cookie file. Actually, it gets me thinking. I believe the electrs is as well. So yeah, both the electors, basically every service that's talks to Bitcoin D via the RPC interface authenticates with the cookie that Bitcoin D generates. And it generated it on every boot. And but these services have access to that file. So I'm gonna make a note with that. Okay, let's delete that. I'll do a circular one since it's a little different. Cookie auth. So this goes in here. Like so. right, so I got the cookie authentication. So all of the RPC accesses from the local services are reading the cookie to authenticate to the Bitcoin D instance. And you can do another quick arrow here. Okay. So, and then LND itself exposes another port. There's also some other ports that I'm actually going to move this. Kind of made a mess of things there. Do this. Can you really see where the arrows are? Okay. And cookie auth coming in. Doesn't look good. Double arrow connector. Okay. Okay, well, I'm not a graphic designer, obviously. So maybe this should be just a one-way arrow. So we need to do it up here. Oh, there we go. There we go. That's probably, it looks really bad, but problem is that there's other ports here, so this is going to be Bitcoin ZMQ 0 message queue. I think that's what it stands for. Can you tell me about ZMQ and Bitcoin? High-performance asynchronous messaging library that enables efficient communication between applications. In the context of Bitcoin, 0MQ is used to facilitate real-time communication between Bitcoin Core and other applications. It's a pub/sub architecture, and it's exposing the RPC interface over that. Okay. Yep. So it's just there's certain things, raw block and raw TX. Those are needed for LND, and so that is exposing a couple more ports. So copy, paste, group. actually going to group all these. And I'm going to slide them up. And this is 2. 3 is ZMQ pub raw TX, and this is 28332 ZMQ pub raw block. ZMQ pub raw block. Gotta make these bigger now. So these are pub sub. ZMQ is a pub sub architecture, and it's a bit more efficient. Otherwise, LND would need to poll for transactions and blocks. So this is a faster way for LND to do that. I'm actually going to get rid of the circle thing. Okay. So do that a bit. And then so the RPCs, I don't like how the arrow is presumptuous where it's going. Why would you put it out there? Oh man, that's so funny. Okay, so this is going to be cookie auth. I'm just going to do a circle because cookies are circle. Cookie auth. That's going to go, actually I'll go from here to, oh, good try. It's actually going there. And then electrs is let's try this bidirectional. Oh, I think this is should be able to just copy, paste. I want this to go on one of these, and this to go here. Of course, that looks weird. So this arrow's weird. If I fix this arrow, the other arrow is weird. Okay, well, I'm just going to do that, and I'm going to do that. And there's going to be a slight, see with this, it actually goes down exactly like I want. We can just add in some arrows later. It's so stupid. Okay. Dotted. And this is dotted. Great. Okay. So, and then we also have some, and I don't know if the ZMQ is, imagine those are, I don't know, are those authenticated? ZMQ pub block authenticated. Huh, okay. I guess it is restricted to what you can actually do, right? You're just, this is actually just publishing raw blocks, and it's publishing raw transactions, and so it actually makes sense that it's not authenticated because it's just serving up information, and it's not, you know, it's, there's subscribers to that information, so it doesn't really need to be authenticated because all of this is publicly available information. This is just straight from the blockchain. So, okay. Then this, I wonder if they have a pub sub. Pub sub, wow. Oh man, we're getting fancy. Pub sub. So this is a pub sub. Style this thing to be round. Oh, it says it's already rounded. Well, I beg to differ. Oh my god, that's so... Okay. All right. Let's see. I think that's just. I need the elbow bidirectional. Elbow connector is what I need. I don't know why it's so. Elbow connector. Oh, right here. Okay, maybe this is what I've been missing. So okay, let's just do it out here. And then we'll bring it down. The arrows are just not really cooperating. We'll send the back. And then we'll do it. Okay, it's pretty. Oh, do that. Didn't want you to do that. Oh, man. Is there one down here I can hook on? I'd like to understand why it doesn't allow. I mean, this technically is a one-way arrow, so. Ooh, close. Didn't want to go there. Did want to go there. Now we'll do this one. Don't want to go there. Do you want to go there? And then this guy, see what it pops to. Ooh, got it right. Nice. Okay. Okay, nice. All right. This is still all internal. And okay. Yeah. All right. So that is painting a pretty good picture. So LND has another port called that it's listening on called at 10,009. So let's see. I'm actually not using that in my configuration right now. Let me make sure that's true. I'm not using RTL at all. The only thing that would be using it would be BTCPay, but I'm connecting over the REST API, so I guess that's another one. And so I'll put so this is another port, and it's 8080 REST API. And this is what's talking. So you have the REST API at 8080, and then gRPC as well. The gRPC is at 10,009. I'm not using the gRPC, and litd is not either. Okay, so actually litd is using it. I had to look it up. Litd is using the gRPC port of LND. Litd is a lightning terminal. LITD, lightning terminal daemon. Litd. So, okay. And BTCPay is using 8080. So I'll draw that in. I guess this needs to be. I'll put that one over here. So this is 10,009. Port 10,009. gRPC. Cool. And extend that. this should probably be, oh, where did that come from? Not sure how that. We're gonna need an elbow connector. Oh shoot. Okay. Bring it down here. Okay. Okay. It's looking okay. So this needs to be extended. And we got to connect these two. So this is going to be BTCPay server. And this is going to be Lightning terminal. What other? That's all of the processes, really. And so then we're going to have BTCPay is kind of like a big ball of wax on its own. And Lightning terminals, straightforward. So, and it's very simple. So this is more of like a litd.service, and they are providing a web server. Let's see. What ports does Lightning terminal listen on? 3001 for HTTPS. Lightning terminal is basically a web application, and they also they're doing some magic with Lightning Wallet Connect, where they allow you to pair your wallet from LND, and then you can access your Lightning terminal running locally and your LND node over the internet without exposing these 3000 or 3001 ports publicly on a public IP. Not really sure how that works. I just started using Lightning terminal, but it's kind of interesting. So this will be 3001. So Lightning terminal talks to LND. So Lightning terminal connects to LND on the gRPC port, and it's authenticated with the macaroon file from LND. And similarly for the communication over 8080 port which is what BTCPay server uses as well. And so yeah, I guess I can note that here. Macaroon auth. The arrow pointing. Over here. And then perfect. All right. And then, ooh, look at that. Okay, great. And really, this is bidirectional, but I'm just using the auth to illustrate that. And okay, so yeah, litd is pretty simple. It's essentially a web app, and it allows you to open channels on the Lightning Network. Gives you a graphical interface, a web interface for opening channels, managing liquidity, doing loops if you want to open a channel and then loop out some in order to be able to receive sats, which is needed for my use case with my BTCPay server and things like nostr. So being able to send and receive zaps, Lightning terminal is a pretty intuitive API for doing that. So I used that, and it's working well. They're also using, like I said, Lightning. I think it's called Lightning Network, Lightning Wallet Connect. Lightning Wallet Connect. Lightning Terminal. Pairing wallets. Lightning Node Connect. Yeah. There's documentation. Lightning Terminal connects to LND. Then you can go to the browser, your browser, and connect to your node with Lightning Node Connect. And then you can interact with your Lightning node from the browser. It's pretty handy. It supports loops, liquidity pools. Yeah, Lightning Node Connect is a new mechanism to smoothly establish a connection to your Lightning node, even if it is behind Tor or NAT. LNC is an open source tool that allows for end-to-end encrypted connection between an application and a node. First implementation of the Lightning Node Connect technology is used by Terminal to enable anyone to manage their node easily over a web portal, independent from where the user or their node are located. How it works. LNC makes use of LND's existing gRPC interface The node makes an outgoing connection to a web proxy to which the user is able to navigate using their browser, which is Lightning Terminal in this case, using a password authenticated key exchange. The established session can be end-to-end encrypted and authenticated between the user and their node. Terminal Connect is implemented as part of terminal in litd 0.6. Okay. Lightning Node Connect. Yeah, I'll have to do a deep dive on that. It's working. I admit I'm not exactly clear on the details, but it is pretty handy. Anyways, so this is still local. This port 3001, it's still local. There is no public IP. This isn't even done over Tor either. And yeah, and somehow, so it's interesting. I'm really curious on what's going on here, because I don't have, because it said it's talking to the gRPC interface, and I don't have this exposed publicly. I don't have it exposed over Tor, and I don't have it exposed on a clearnet IP address either. So now the LND itself is accessible over Tor. So yeah, I'm not sure. I'm not sure how that's working, but maybe that's next time. So the next part is BTCPay. BTCPay has a lot of dependencies. There's a great instruction manual for setting up BTCPay. I wanted to do a manual setup, so the extended manual setup, because when I first started reading about BTCPay, it was unclear if BTCPay would start its own Bitcoin D instance and LND instance. And I wanted to make sure that it was using my already running Bitcoin and LND. So I didn't want to have to download the blockchain again or any of that stuff. It wasn't clear how I could do that. That there's, like, if you use the default deployment method is, there's a bunch of one-click installs, and there's even a Docker. If you want to install it yourself on your own machine, but you just want it all to be automated, then they have a Docker script. But it was very unclear how to point BTCPay to my already running Bitcoin Core and my already running LND. And I just wanted to learn how it works. So I did the extended manual setup, and yeah, there's a big red warning that you must have technical literacy and be able to resolve any issues on your own. The community will not provide extensive support for this deployment. Well, luckily I haven't had much of an issue. There's one issue I'll go over later that I actually submitted a PR to BTCPay server code to fix it, and got it working. But honestly, this page right here is what I followed, and it's worked well. So let's see. They go through, yeah, there's really, you can copy the follow these instructions. You install PostgreSQL as a database. So I did that, and the things that I did, some of the things that I already done, like I already had Tor running, so I didn't need to download Tor again. Postgres I needed to, and the stuff that I needed to is here, set up BTCPay node. Those are the commands that I needed to run. And so, yeah, so nginx, this is a big one. And this kind of gets back to the point of the original need is I needed to host this BTCPay server so that it can be reached from the clear on the internet. So not over Tor. And so the solution that I ended up going with is renting a cheap T2 Micro AWS EC2 instance, and then setting up nginx as a reverse proxy back to my my device running in the closet. So I'll be drawing this, but nginx reverse proxy back into the closet PC. That's where BTCPay server is actually running, and all the traffic gets proxied through nginx. It gets proxied to the EC2 instance with a SSH tunnel, and then it gets proxied to the internet through with nginx.